Hey, good afternoon, everyone. My name is Seth Shanahan, and I work with the Southern Nevada Water Authority, and I serve as the Colorado River Program Manager. I want to thank the meeting organizers for the invitation to talk to you today about SNWA's perspective on this topic of drought assessment in a changing climate. So here are a few of those questions that I'm going to answer today, but before I get to them, I want to give you a little bit of context and understanding about SNWA. SNWA is a not-for-profit wholesale water provider, and we were created in 1991. We actually provide water to more than 2 million people who live in Southern Nevada, but then also have more than 40 million visitors to our area, particularly here you can see on the Las Vegas Strip. The economic output for our area is about $93 billion of GDP, which is about 2/3 of the state GDP. So Southern Nevada Water Authority provides wholesale water to our utility customers. And you can see here a map of our service area on the left-hand side and all of those utilities. One thing that I'm not going to talk about today, but want folks to also understand that we look at in Southern Nevada, is some of our small groundwater dependent systems too. But again, like I said, we'll talk about that another day. So here you have a graph of the water cycle for Southern Nevada. And the important part of this I want people to understand is that SNWA gets about 90% of its water from the Colorado River, and we access that from Lake Mead. The other 10% of our water comes from local groundwater in the Las Vegas Valley. The other element of this I want folks to understand is that for all the water that we're able to use indoors, and we can capture it like that and treat it at a wastewater treatment plant, we can discharge that through Las Vegas Wash, and Las Vegas Wash flows back into Lake Mead. So this is a really important element of our water recycling that we do in Southern Nevada, trying to capture as much as we can indoors and not lose anything outdoors. Because we get so much of our water from Lake Mead, we're of course very interested in its status and condition. Here we have a couple of figures from the Bureau of Reclamation. On the left, there's a Lake Powell figure. On the right is Lake Mead. And for the Lake Mead figure, I want you to look towards the bottom and to the left, because what you're seeing is on that gray column, different elevations of Lake Mead that as you drop through them indicate that you can be shorted a certain volume of water because of that. And that's really important for us in Southern Nevada, that if we get to those elevations, and in fact we're at and below some of these already, that we get shorted a portion of our supply. Now that you have some perspective about SNWA, I'll move on to some of the questions asked by the organizers. All right, so the first question was related to how decision makers are employing current drought assessments. Well, on the left, I want to say that hydrologic drought assessments are very critical in the basin and to us here in Southern Nevada. One of the most important, or I should say the most important, is the water supply forecast that comes from the Colorado Basin River Forecast Center. And the reason why that's so important is that that information gets fed into a reservoir projection model that's run by the Bureau of Reclamation at various timescales, actually. And then those operating decisions, as I mentioned on the one of my previous slides, are some of the major decisions that gets made in the basin about shortages. So it's really that workflow that is the most important element when it comes to drought assessments. So on the right side, then you'll see some other drought assessment information, which is helpful but not very decision specific. And so that's what I want to make a distinction between the left side of information and the right side of information on this graph, on this slide. So on the right side, you'll see that all the other information that we see out there, it could be anything from soil moisture or snowpack. A lot of that is just simply general situational awareness. It just helps us understand what's going on out there. The other element of that information is that it can support our level of confidence in something like a water supply forecast. You know, if we have lots of lines of evidence, that could be useful. It could also be very useful when it comes to trying to improve the information workflows that we currently have. And so that I don't want to discount, because that can be very helpful. And then the other or last item here is just that it can be used for ad hoc decision support. And these might just be very small decisions that are made. You know, for us at SNWA, we try to always encourage people to turn off their watering clocks, for example, when it's raining or about to rain. And so some of that kind of information can be very useful there. So I was also asked to answer if there's any gaps in knowledge that we've identified. And fortunately, I'll say that many years ago, my agency partnered with many other agencies in the Colorado River Basin in a group that we call the Colorado River Climate and Hydrology Work Group. And we actually commissioned a report to get to precisely that kind of information. And you can see that here on the right side. It's the State of the Science report that we call it, and it was published back in April of 2020. And in this document, there's more than 70 different gaps in knowledge that were identified. And we don't actually use that term gaps. We instead use the term opportunities, and those are opportunities that are developed from the different challenges that we identify within this document. So on the left side, you can see just an example of that. That's under the streamflow forecasting chapter, that one of the challenges is related to the lack of a hydrologic forecasting test bed, and consequently the opportunity is that perhaps developing a test bed could be very useful. So I just urge everyone to go visit the State of the Science report, and you can see a whole laundry list of different opportunities there. So why is non-stationary climate consequential? Well, for us, the increased warming that we're being subject to now and also projected for the future is leading to reductions in Colorado River flow. And the best studies indicate that we're going to see for every 1 degree Fahrenheit of increased warming between 1.5 and 7.5% flow reduction. And that's pretty big for folks who rely on the Colorado River. As the Colorado River flows decrease, ultimately what happens is the reservoir elevations drop if you consider that demands stay the same. And that's precisely what's happened over the past 20 some odd years. If you see on this figure on the left, you can see where we started 20 years ago or more at a very high combined reservoir elevation of Powell and Meade. It's declined quite a bit as you move to the right of the graph. And that's important because here on the table on the right, you can see that at the different Lake Meade elevations, the different states of Arizona, Nevada, and California get cut a portion of their water supply. And of course, you don't have to be too far away from your Twitter or Facebook to get these kinds of posts about concerns over water in the West right now. So here we have just the question regarding if we've changed our drought assessments in the face of this non-stationarity. And I'll first by saying that we accept the future realities of a more arid climate. And this is a figure from Ficklin about a decade ago that just looks at future aridity given different climate projections. And it is of the upper Colorado River Basin. And you can really just see that marching of more of those warm colors indicating that it's going to be a much more arid future. One of the ways that we've already changed when it comes to considering the non-stationary climate is about what kind of future Colorado River flows do we expect. And here we have a graph that I've adapted, which effectively shows the temperature-adjusted flows, mean flows of the Colorado River. And there's quite a bit of range, but for our agency, we've actually adopted one of the lower ends of the range, which is an average value of 11 million acre-feet per year. What we do in our agency is we develop an annual plan known as the Water Resource Plan, and it projects out water supply and demands over a 50-year period. And so by taking a very low average Colorado River inflows of about 11 million acre-feet and running it through various modeling scenarios that you can see on the left, and then we compare those results with what our water supplies look like on the right and determine if those two pieces of information match up. So that's one of the ways in which we've been able to consider the non-stationary climate and how to plan for it for the future. Thank you for listening to me. I hope I gave you a flavor for the issues in Southern Nevada and maybe more broadly about the Colorado River Basin. And if you want to get in touch with me, you can find my email and phone number there. Contact me anytime. And I look forward to having future conversations with everybody. Thanks again.